Enval is a company that is commercializing a process to recycle something called plastic aluminum laminates. Plastic aluminum laminates are the materials that are used in toothpaste tubes, cosmetic tubes, coffee bags, pet food pouches, things like that. There are materials that the fast-moving consumer good companies, FMCGs, are using a lot and are increasing their use because as packaging they are very, very good. In fact, laminates from a sustainability point of view and from a financial point of view tick a lot of boxes, and as a consequence FMCGs really like them. Unfortunately, the last box, that is recyclable, is not ticked. They are very light, they protect the food very well, they are very economic, etc., but they are not recyclable. And that, at the end, might come and be a problem for the companies using it. Why? Because the consumer only sees that they are not recyclable. They don't necessarily know about how good they are in many other ways. As a consequence, FMCGs really want to have a process that can recycle these things. And Enval has developed the first commercial process that can recycle them, recovering the aluminium that these materials have embedded in it and turning the plastic into an oil that also has a commercial value. And at the same time, we obviously are preventing many tons of valuable materials from ending up in landfill. So the company is a company that has a dual proposition, a financial gain, obviously, and a sustainability gain from an environmental perspective. What makes Enval's technology unique is that it uses a process that can extract valuable materials from this type of packaging at the right level, given the geographical distribution of the waste. We call it, well, we say that this waste is a geographically distributed problem for which we need a geographically distributed solution. That actually means that the process can actually be scaled down. A lot of people think that economies of scale need to be exploited by making things larger. And in the waste sector, we think we Enval think exactly the opposite. Waste consists a lot of air and water, and moving air and water is very, very expensive. We are totally convinced that the way forward in the waste sector will be to have much more dedicated small technologies so that waste is treated locally where it is being generated. Now, there are some things about the Enval technology that allow that to happen, especially for materials like the laminates. It gets a little bit technical, but it is by the way in which the heat is transferred to the waste so that we can paralyze the plastic, which is what we do, recovering the aluminum. And that has to do with heat transfer coefficients and things that are technical, but the point is that there are unique things on the Enval process that allow you to do a small process that is financially attractive. Enval got going from a process that was developed initially in the University of Cambridge. This was a research project, it was a PhD project, then it became a postdoctoral project. And at some stage we spun it out from the University of Cambridge, originally from the Department of Chemical Engineering. In 2005 we submitted a business plan to the business plan competition in the university. We won that competition, and as a consequence the company was spun out. Initially we received some backing from a number of business angels from the Cambridge area, some very well-known names in the Cambridge area. We built a pilot plant, we proved the pilot plant to investors. That gave us the next round of funding. We moved the pilot plant to a more industrial-like setting, that was in Luton. We operated the pilot plant in Luton for 3 years. That brought more investment on board, and now we are in the ramping up of our first commercial scale plant, which is in Alconbury. So in summary, it has been a journey of development from a very small reactor in the department in the university to a commercial scale plant that produces aluminum on a commercial basis. Everybody knows recycling is something that has grown substantially, not only because of regulation, but because people are actually caring about the materials that we use. So this dual thing of people actually caring about it and governments trying to do something about it means that the recycling rates pretty much all over the world have substantially increased in the last few years. In fact, from certainly point of view, that's why laminates have grown a lot lately, because one of the reasons why they are very good is because they are very light, and they substitute things that, even though they're recyclable, they are very heavy. People are more and more conscious about not using so many resources. So laminates have grown a lot. Part of that growth has been because they are very good from an environmental perspective. In terms of tonnage, for example, in the UK there are something like 160,000 tons of laminates growing at nearly 15% a year. In some other geographies they are growing at up to 50-55% a year. So their use is growing a lot, and at the same time governments around the world keep putting legislation in place so that more and more materials are recyclable. That obviously is a very good thing for companies that are developing processes in their recycling area, like Enval, and we are certainly making the most out of the trend, if you know what I mean. Is something that we do because we believe in. It's not something that we do simply because of legislation. We believe it's the right thing to develop processes that will prevent materials from ending up in landfill, especially for materials that we know are saving a lot of resources in the first place. So the numbers are growing, the legislation will still be there, and we need to make the most out of that opportunity. Enval as a company is not a waste handling company. So we are, as I said before, a spin-out from the University of Cambridge. We are a technology development company. However, in the waste handling sector, which by the way is very, very conservative, there's always the issue of the chicken and the egg. No one will collect materials for recycling if the process to recycle them doesn't exist. And at the same time, no one will develop the process if the materials are not collected. We actually managed to break that circle, that vicious circle, by getting the investment and developing a technology for materials that, although exist in the waste, no one is really collecting post-consumer. Now we have a commercial scale plant for this process, and we are using that commercial scale plant with material that come from the pre-consumer side of the supply chain. In other words, there is a lot of waste generated while the packaging companies make the material in the first place and the FMCGs use the material to pack their products. There's enough waste there to fill the capacity of our commercial scale plant 3 times over, just in the UK. Now that we have the commercial plant operating, we effectively have become a waste handler. It's something that we did not envisage at first, but we needed to become one in order to showcase our plant to all the others. Do we intend to do that in the future? Not really. We needed that first one, and now we can use that first one as a showroom to show it to all the other companies that are waste handlers so that they can see the process operating at a commercial level, and they are convinced that it will actually work for them as well. Parallel to that, the next question that potential customers have is, where are we going to get the materials from? Where is the collection? Well, currently, Enval is engaged in a project that is sponsored by DEFRA, by the Department of Environment in the UK, in which 3 local authorities are telling people like you and I to put the laminates in their recycling bin. Those materials are going to the local separation plant, and they are being separated, and they are brought to our commercial plant for treatment. This is a trial to show to the waste handlers that if they asked people like you and I to put the laminates in the recycling bin, they would put them. In other words, it will demonstrate that the availability of the raw material for the Enval process exists, is there, people will put it in the recycling bin, and they will have enough material to run their plants. So our proposal for our customers is to design, build, and deliver a machine that they can put at their separation plant, ready to treat the materials there and then, without need for transportation, in order to get valuable materials that they can sell, meaning the aluminum and the oil, obviously, and at the same time they avoid tonnage of packaging going to landfill. They can pay for the investment in a very attractive way with a very good return of investment, and at the same time have more boxes to tick in their sustainability compromises with their customers. The original IP was developed in the University of Cambridge. The core patent of the process was protected by the University of Cambridge. Enval has a worldwide exclusive license for that patent, which is, as I said, for the core of the reactor. Subsequently, during the development of the commercial scale plant, Enval has developed new IP, and we have 2 patents ready to be filed. We are just doing the last details of those patent applications, and we're expecting to file them very soon. At the same time, there's a lot of know-how that is not necessarily patentable, but that it is totally well documented and that we are using to protect our market share eventually. We have the advantage that there are no other processes in the world currently that can do this, and therefore we need to move fast. We need to make the most out of the first mover position in which we are, and we intend to do that with our patents, with our formal patents, and with our non-patentable know-how. Currently, there are no real competitors out there. At the end of the day, we are competing against what traditionally happens to these materials, which is landfill or energy from waste. Especially in Western Europe, the energy from waste plants are being multiplied by the week, literally. And yes, these materials can go and be incinerated to produce energy, but the valuable aluminium that is inside them will be lost in an incineration case. So what we want to do is to be able to proliferate our technology very quick, so that the materials don't end up getting to energy from waste in the first place. There are other processes that could extract the aluminium from these materials, but they are very specific for example, chemical dissolution for clean waste, which doesn't happen very often in waste, or for very large capacities for example, the depulping waste from drink cartons, which is, as I said, a very specific thing, and there are only 4 or 5 places in the world where you would have enough tonnage to justify those processes. At the level that we are operating, which is the right level for the way in which the waste is distributed, there are no other processes that can deal with this material. Well, the company is led by Martin Lam. He is the chairman of the board. Martin has 35 years of experience in industry. He used to be managing director of a company that was bought by a large PLC. And he is very good providing the business advice, or providing me with the business advice as a mentor. I am the managing director. I am a chemical engineer by training, and then I did my PhD in Cambridge in chemical engineering. It was my PhD that led to this project. I developed the process during my time in the university. I worked as a chemical engineer before coming to Cambridge. I'm from Mexico originally, and I worked actually developing chemical plants. So the technical part of what we do, I have previous experience. We have also a business development director. His name is David Borman. He has many years of experience exactly on the interface between small SMEs selling technology to large companies, which is exactly what we are doing now, convincing the large waste handlers that they really want to buy our technology. That's the core management team, and at the same time we have very good people on the board that are representing the investors that have a lot of experience, both in the technical development and also on the business side of things. Mainly Hugh Parnell, he is very well known in the clean tech sector of the UK. He has a lot of connections and he has a lot of experience in terms of finance and SME growth. And Peter Briggs, which is one of our board observers, which is representing business angels, and he has a lot of experience, again, growing companies, especially in the industrial area. The board has always kept in mind that we need to provide some liquidity to our investors in the not too distant future. Some years ago, when the IPO market was not in fashion, we knew that that was going to potentially be a trade sale. Having said that, because of the way in which the economy has moved, we have actually now started to consider that an IPO could potentially be a very interesting route for exit and to provide that liquidity to our investors. As a consequence, Hugh and Martin, our non-executive directors, have actually started having some very initial conversations with the people in charge of cleantech at AIM. And at the same time, obviously, we have a very good relationship with companies that supply equipment to the waste sector. So although I'm not discarding at all a potential trade sale, at the end of the day, as a small company, we have to keep all our eyes open and make the most out of any potential opportunity. And at the moment, we can see those possibilities, the trade sale or the IPO in a 4-year scenario as a real possibility. The commercial plant, the commercial scale plant that we have in Alconbury is currently being ramped up in operation. Yes, we did have some teething problems, as any new technology has last year, but we have now solved them. So we now are raising money to provide the working capital that we need while we do that ramping up in operation. At the same time, we know from the experience that we have gained so far that there are a couple of improvements that we could do to the commercial plant, simply so that our potential customers can see them implemented in the Alconbury plant. And at the same time, we know that we could hire a couple of people more on the commercial side of things to accelerate the deployment of our technology with potential customers. So that's why we are raising funds, and that's what we would use them for. We have been very fortunate. We have received many awards. Amongst others, we received the National Recycling Award a couple of years ago for the best new technology. We received the Finance for the Future award from a relatively odd source for the waste handling sector, which was the Institute of Chartered Accountants of England and Wales, and that was for the best idea on how to do the financing for a new technology. That was to do with the way in which we built the Enval Consortium, which is a vehicle by which some companies, FMCGs, helped Enval paying for the first commercial plant. In fact, the Enval Consortium was built with Nestle, Kraft, and Mondelez International, which effectively gave us money to build the plant in Alconbury as effectively a donation to Enval at no cost to our shareholders, so that we could have the plant to showcase it to the waste handling sector. So that's we received the Finance for the Future award for that idea. We have also been highly commended in several other award ceremonies, and we received the award for ACE, which is an academic organization in Switzerland, for the best chemistry project brought to a commercial reality as well 2 years ago. So yeah, we have received several awards.